Hi, I'm John Nettleton, and this is the latest episode of DevCuts. Today I'm going to be going over our latest i.MX 8MP BSP release and some of the features that we've enabled in that software update. First, I would like to talk about a new thing that we've added for this series, where in our community forum, you can see down here at the bottom, we've added a SolidRun DevCuts community discussion topic, and what I'll be doing is for each release of a video that I put out, I'm going to be putting specifics that are developer focused, Git repositories, source code snippets, links to other places and information that you can find about the developer topic that we're covering. So for instance, this one will point to the new Yocto release and all that sort of fun stuff. And then what you can do is, of course, you can use the YouTube comments, but otherwise you can have a discussion about what we've enabled in the BSP release or in the DevCuts topic and interact with other developers who are also trying to do the same thing. So with this release, and here I will switch over to my screen. We can do a quick reset, and you can see it booting. This is this is Yocto Hard Knot, and it's using NXP's latest BSP. It's based on that, so it's a 5.10 kernel. But we're really excited because with this release, a lot of the hardware features are now fully supported on our boards. Specifically, dual Basler camera support is working. I'll show that to you in a little bit. But we've also added a few other tweaks in order to make this a much better distribution for our embedded customers and for remote deployments. First, you see it boots up nice and fast. This isn't overly optimized. This is just an out-of-the-box image that you would build, and then log in. One of the first things that we've done is added a driver and device tree entries, so we have all of the wireless modules, even if they're not populated. So on our boards we have an M.2 and a mini PCIe slots on the bottom for our HummingBoards, depending on the model you have. And generally these cards have GPIO pins that tell the card to turn on and off the wireless or the GPS. And traditionally you would have to just leave the GPIOs exposed to user space and manage them there, or just drive them always on so the device is always functioning. What we've done is instead made it so in device tree we can describe those GPIOs and expose them to RF kill, so you're in full control of the cards that you've installed in those slots. So you can power up and down the wireless radios, or you can enable or disable the GPS as you want to save power, for security reasons, whatever you want. This is a really nice feature for embedded, actually managing the add-on cards that you can have installed in there. The second thing that we've added specific to this BSP is user space access to the regulators. This is another thing that isn't in mainline, but for a lot of our customers is very important. If they have a USB device attached, they might want to hard power that down and to save power. Or they might need to reset it. Maybe it's a failure and the device is deployed. And traditionally, again, this is something where we have regulators that are driven by GPIOs, but there's no good way to access that in user space unless you write your own custom daemon. And instead what we've done is we've added platform devices that are also described in device tree. And see here we have power M.2 PCIe, USB port 1, USB port 2, and those are user space interfaces to basically power up and down VCC regulators on those ports. The mini PCIe and M.2 are a single. They controls both cards, but then each individual USB-A port has its own. And it's just a nice feature. If you don't need it, you don't have to touch it. And of course it can be disabled in device tree if you don't even want it there. but most of our customers, this is a real value add, and it makes it an easy way for them to control the hardware connected to their boards. So with the last little bit I want to cover, I'll be doing more of this later in the week. This is really going to be a 3-part mini-series where I'm doing the basics of the new BSP. The next episode I'm going to be doing neural networking acceleration, talking about some of the things we've done and found that allow us to optimize the basically the camera inputs, parsing the video data before running it through a neural network in order to get a nice frame rate and really good results. And then following that, we'll be doing another one, which are some specialties. Before I go into that further though, why don't I show you the camera working. And here, this is the Basler Camera Kit connected directly to the SOM. This isn't going through the carrier, which was the only way for it to work previously with this BSP. You can use either or MIPI CSI connectors, and you can actually use them both as well. So here you go. We will fire up the camera and then switch over, and here I am. Again, this is the camera that is it's actually upside down right now, and so I'm using the ISP to flip the X and Y axis and produce this image in its proper orientation, all of its hardware accelerated. It's all nice low latency, so it's a nice little addition. And that basically covers all of the BSP. We're really excited for it. We're excited to see what our customers can do with it. Like I said, next episode, which will be out on Wednesday, will be us showcasing some neural networking and machine learning demos and vision processing. And I'll be talking about some of the things you can do with the Basler Camera Kit. And then the following Monday or Wednesday, I will have another video up, and that's going to be a specialty video about things that our customers have asked about that I think are interesting, and we've enabled, like the running the USB port, OTG port in device mode, the performance, which I'll give you a spoiler. It's actually really good. Over just a network interface, I'm able to get about 2 gigabits per second, which is excellent for USB 3 in device mode. And I will also be going over some tweaks you can do to do low latency video streaming. I've been able to cut that down even with neural networking inferencing to about less than 100 milliseconds, in some cases down to about 80 milliseconds, which is ultra low latency. And that's super interesting for what you can do with that, as far as live video streaming with neural networks, with actual neural networking running on top of it. So that's all really exciting stuff. Check out the community forum in the new DevCuts feature section, and like, subscribe, keep an eye on Twitter or LinkedIn, wherever you find this, for the next run of videos. We're really excited about them, and have a good day.